Good evening, everyone. Hello, can you guys hear me? All right. Good evening, everyone. And how are we doing so far? How's our React? How's it going? I hope everyone has been practicing a lot on the React and working on all the projects, practicing on all the tools we shared. All right. So today we are going to kickstart our backend journey. So I believe we've talked about this some times ago, letting us to know about what backend is. Can you guys hear me? I need to know that you guys are hearing me. All right. So, and our major focus on the whole backend for the rest of the mentorship program is going to be on Node.js. So, we're going to introduce ourselves to what backend is, what database is all about, how to architect and scale a backend system to handle large data sets and loads. We're going to talk about all those things through the remaining session on the program. All right. So when we hear the word backend, what do we think about? What do we even think backend is all about? Backend development is just the process of building a server-side logic and database interaction for web application. Can we just pay attention to this sentence? The We should notice for three things here: the server logic, database, and web application. So, backend is all about these things. When we talk about front end, we only talk about the UI and the design. That's what we talk about on the front end. But when we are talking about backend, we talk about a lot of things. That shows how big backend is. Backend is very wide. You deal with database load, you deal with server load, and you deal with the logic that react, that behave on the server and the database. Do you understand that? The server, the database, and the logic on how they behave, and also how the web itself behave. You supply API for the front end to integrate into their web application. You supply API to data science department for them to build their data analytics system, the metrics. You supply API to the mobile app developers. These are the things the backend do. And these things is not just writing API. The API is fetching data, is retrieving data from one place, from the database. All right. So, what are the key responsibilities of a backend? Managing database, which I just explained. You are going to be working with a lot of database like MySQL database, MongoDB database, Postgres database, to mention less. Handling server-side logic, understanding and building a complex logic. An example is handling a payment system. Customers should be able to make a payment before they can print a receipt or access a portal. When you make a when you try to order food, you need to make a payment. Your payment needs to be verified before you get access to the food. Your order can be placed. These are server-side logic. These are the server-side logic. And the logic is not just behaving on itself without database in charge, handling all these things and storing all this logic. Then processing requests and responses. This is very important. When you talk about requests, when you try to log in on any application that you are using, at the backend, you make an API request to log in. When you make an API request to log in with wrong credentials, the response you get from the API will be a failed response. When you make an API request to log in with correct credentials, you get a success response. The logic that will determine and verify the credentials you input is on the server. Handling the server logic for the application to perform very well is very, very important. You write an SQL query to verify user credentials. You only need to select the data you need in your database. You don't select a whole columns of user to fetch data because it might affect the performance. Imagine a million or 1,000 users is trying to access their projects, their web portal, trying to log in at the same time. Thousands of users. That's like 1,000 requests on your server. 1,000 requests load on your server and your database. And if you are trying to select a lot of a whole column that belongs to the user, so the response time for that request is going to be large, it's going to be much. So it's called the latency. So when we are talking about the backend development, you are not just talking about how to write an API that do crude application. We are talking about on the large scale system here. You are building a system that is very, very scalable and can perform at a high level. And we also talk about the security. What do we mean about security here? We all make a payment on the system. We all make payment on the web system, web portal. We input our card information. We try to log in on the server. We input our password. All these things are system that should fall under security concern. We migrate, we move data from one web portal to another portal. Encrypted information, health record. All these things are things that falls under security. Also, when we talk about security on the large scale, on the large part of it, this is where security comes in, like we securing the server from unwanted attack, like hacking. When we think about security, we should think about the attack. So backend system need to undo all these things and put in place a check, a metric. So sorry for that. So to put in place a check to handle that. All right. So we now have front end and back end. I believe we've talked about the front end parts before, and we've walked ourselves through what front end is all about, and we've practiced some things on front end. And we've worked on React, which is part of the things we've done in the previous session. So here, part of the things we understand as a front end system is using JavaScript to work with React, work with Angular or Vue.js. But here on the back end, we are going to be using JavaScript. All right. So now, what do we now understand by the back end? The engine that powers the front end, handling the data processing, storage, and the application logic. This basically break it down for us again, like provide more insights on what backend is all about as a whole. So when we want to start working as a backend developer, we need to prepare our mind on the things we are going to be doing, and we need to be very good across all these things listed here. So as the time goes on, we are going to be talking much about all these things. So server-side programming languages. What are the things? What are the languages that we use to design or work as a backend? So there are a lot of programming language that support the server-side system, such as Node.js, Python, PHP, Ruby, C Sharp, and Java. These are top languages, but they all have different performance, different architecture, and the decision is for us to choose the one that best suits what we want to build. Now, for this mentorship program, we are going to focus on JavaScript using Node.js. We are going to understand the architecture of the Node.js, because it said JavaScript runtime is built on Chrome V8 engine. What does this mean? It means that the engine that run on this JavaScript is a V8 engine, and it's being run on our Chrome. When any JavaScript that you write, you can basically just run it in your Google Chrome browser. If you have any web browser, you can run it on it. And when you set up, if you guys remember when we set up the React the other time in our front, when we start the front end class, we install Node because it's also run to run a React project is built and run on Node. So do we guys have any question before we move ahead? Or are you guys on do you guys understand? Are you guys there? Can you guys hear me? All right, so we are going to be using Node.js, and also we also have Python. It is known for its simplicity and readability. Python is very simple to use, and it's very light as well. So, and also a popular frameworks. It supports Django, Django is like a fully ready-made framework for us to use. But Flask is a very light version of Django. All the things that you need to implement yourself in Flask has been already implemented in Django. So if you are looking to get started with a ready-made framework, you can go with Django. But if you want to get your hand dirty, you want to set up all the server configuration yourself, the responses, you want to design your responses yourself, your requests, your middlewares, everything. You want to design it yourself. You can get started with this Flask. All right. So, and as well, you can also check out the rest of the programming language, such as PHP. We have Laravel. It's like a version of Django, a ready-made frameworks. Everything is already built into them, into Laravel, same way as Django. But Laravel is for PHP. And if you want to find alternative version to Laravel, you can go with a Slim framework. PHP Slim. It's called PHP Slim. It's a lightweight PHP framework. The same way you have a lightweight Python framework, which is Flask. That's why we have PHP Slim also. We also have Code Igniter, so on and so forth. All right. And also for C Sharp, the most popular framework in C Sharp is ASP.NET. And also for Java, Java is one of the top and the biggest JavaScript backend programming language. And for Java, the core framework we use in Java is Spring Boot. All right. So we have Ruby. Ruby is designed for developer productivity and happiness. I don't have experience writing Ruby, so I don't know much about Ruby. But the popular framework people use for Ruby is called Ruby's on Rails. If you find yourself in all these developer groups, you read people's code on GitHub, Twitter, Reddit, you must have heard of Ruby's on Rails. I'm familiar with PHP. I write PHP. So PHP is also light, fast, and the popular one of the popular framework is WordPress. This is a framework used for um, to design all these web system, all these templating engine system. So WordPress, but I don't have experience working with WordPress. All right, so yeah, we are going to be comparing all this server side language to understand why and how they works. So when you think about Node.js, it's very fast. The light framework language, easy to scale. What we mean by it is easy to it's scalable. It's easy to scale. When we get started with Node.js, I want us to have one thing in the back of our mind and go and read up on it. How Node.js system actually works. Node.js is event-based system. We have something we call event loop, and Node.js system is a single threaded programming language. What do we mean by that? Let us assume we have a single request. A single request is being used to serve the whole application. So when a single request is being used, a single thread is being used to fetch data from the database, or is being used to perform a large logic. When another request comes in, it will have to wait until that first request, the thread finishes all operation on the first request and return the response before it can pick and serve the second request. So now, initially, you can scale this system not to be a single thread. That's where you look into all the Node.js functionalities that enable you to have a multiple thread and handle multiple requests on your application. Read up into what we have: the child process, the fork, and a whole lot of things. So, and also is an event-driven system. Like I said, event loop system. And also it support a full stack application whereby you have your front end and your back end. You use JavaScript to build your front end, use JavaScript to build your back end. You use JavaScript to build your mobile app. You use JavaScript to build your the data analysis tools and so on and so forth. And it's being used to build a real-time application. When you think about Node.js, you think about Node.js, a real-time system, like a chat application that supports sockets.io, supports um, when WebSockets and so on and so forth. You can use it to build a chat app. You can use it to build a real-time system to keep track of your activity on map. So whereby you keep emitting events every time the data is being utilized on the map. So we used to build API. Also for Python, when you think of Python, you think of AI and machine learning. That's on the high end. Most people that build AI, build models, machine learning and all, they basically use Python because it's solely and supports the community of Python is highly big on AI and machine learning. So it's also used to build web apps, AI and automation. So and also we have Ruby. Like I said the other time, I don't have much experience on Ruby, but I have experience working with PHP as well. So PHP is easy to develop, to deploy, integrate well with databases. Yeah. So PHP is used to build a CMS. What do you mean by CMS? A CMS is a content management system. So that's where the WordPress part comes in. So it's also used to be the web apps, like the application that we use. All right. So now this is where we now talk about the database. Like I said, we all understand that database is used to store data. Basically, that's what database is all about. Is where we store data, and it's part of the backend engineer task to understand how database perform. Not don't just understand how to save your data in your database, how to retrieve your data from your database. You also need to understand how the database perform, which data is best suitable for this type of data. So we have something we call NoSQL and SQL. NoSQL simply means no structured query language, that is SQL. And also we have SQL database. What do we mean by no structured query language? It simply means a data that can be saved in a flexible data model. That is, you can save in a specific data model. You can save it as a JSON, you can save it as an array, you can save it as a string. But when we are talking about structured query, no structured query language, all your column, you can you can you can save it without having a relationship. You can have a single model to handle a user. Under the model for the user, you can also have a data key value to handle the key value pair or documents of user address, user health record, user books. user relationship, user family tree under a single model. It will not have relationship. But when you are dealing with structured data, that is structured databases, which is relational, this model that I explained on the NoSQL, which hold a single model, on in the structured query language, you have to split it to multiple model. You are going to have a user model, you are going to have a family tree model, you are going to have a user address model, and so on and so forth, whereby you are now going to have a relationship between the user and the addresses. This is where we have multiple relationship. When we get started, when we get into database, we are going to deal with how relationship work. We are going to introduce ourselves to what we call relationship in database. That is where we have one-to-one relationship, one-to-many relationship. That is an example I cited the other time, where we have the user to address. A single user inside the database on our web application can have multiple addresses. If you guys use an e-commerce platform very well, or you guys use a food ordering application such as Chowdeck or Jumia, when you go to the address book on the system, you can add multiple addresses, which is your delivery address. On any e-commerce, a user can have like 10 delivery addresses. That kind of relationship is called one to many. A single user can have multiple addresses, and you can save it in a two database. You are going to have a table to hold the user and a table to hold the address, structured data. But we are dealing with no structured data. All you have is a single data where you have just the model of user and had everything relating to user model inside the user model. No relationship. All right. Do we all understand that explanation? Do we all have any question? Do we understand? I should continue. Carry on. So I'm trying to let us understand what we are going to be dealing with on the back end. We should prepare our mind the same way we did for the front end. Introduction to how the database and backend system works. What are the things we are going to be dealing with? It's go more beyond just writing code. When you are working as a backend engineer, it's go way more than writing code. You need to understand all these things. All right. In the absence of no question, I will continue. All right. So now, when we're now talking about a structured database, this is where my SQL and Postgres comes in. What is a MySQL? MySQL is an open source relational database language. What do we mean by open source? Things that is very open to all developer community. You can contribute to it. So relational database language, that is, it's it's a structured database, support the structured data, and known for reliability and the performance. What do we mean by that? It is very, very reliable and its performance. Now, I want to explain something to us in terms of database. When we come across anything called performance on database, what comes to our mind? What comes to our mind? How how the database perform, right? Imagine we have a database. Let us assume like a database of schools that hold schools information and students information and students academic records, courses, teachers. This is like a database with thousands of records. The database need to perform very well, whereby when the students need to access their records, let us assume we have like 5,000 or 7,000 or 8,000 records students. That's a single table, student table with 8,000 records. 8,000, a single table holds 8,000 records of students. That's like 8x or 10x of relationship. A single student will have academic record that fast across like 2 years academic record. That student should be able to retrieve all the academic record easily without lagging, without having data timeouts that the system cannot retrieve your record. I believe one of us will have this kind of experience whereby you want to access your portal, the system is not responding. The database might shut down because you wanted to read through all these 8,000 records. That means the performance is very, very slow. Now, the terms scaling now comes in. How do you scale this type of database? Whereby when a student want to find his record in a thousands of record, it needs to read through this 8,000 record in a single seconds, like 2 seconds or 5 seconds or 1 seconds. Now, that's where performance and scaling come in. To do these things, in MySQL, in database performance, we need to implement something known as, there are multiple ways to implement performance and scaling database. So I will try to explain some of them to us in a layman terms so we can understand it. We have something we call indexing, whereby we index a database, that is, you prioritize the column that is used to search through a record. So when we have an 8,000 records, the column has been indexed serially and is written into the memory. When you want to look through these 8,000 records, it's going to use the index column to filter out data within the 8,000 record and get it as fast in seconds. So when the API that is waiting to fetch this data for us, we only load and get data back in a split seconds. That's where the reliability and the performance comes in. The database can hold thousands of records, and at the same time, it can release data for us, go through these thousands of records in a seconds. Now, we now have something we now call the database scaling. What are the ways to scale the database? So in a programming language that we're dealing with, or maybe as an engineer, we might come across something we called horizontal scaling and vertical scaling. So this word is very, very crucial for us. So you can scale in or scale out a database. And when we talk about the horizontal part of scaling the database, is the part where we split the database, we shard it. We have something we call database sharding. And we have another method of scaling called partitioning. So, all right. So horizontal scaling means that we had more server load. We increase the size of the server of our database. Maybe we are running it on a specific, maybe 5 gig or 10 gigs data and gigabyte server configuration. We can add more size, more disk to the database, and that's the horizontal part of scaling database. But the vertical part of scaling database is where we start to implementing our sharding and partition, in the sense that, for example, the user column I explained the other time, you can split all the records on a specific user table to multiple tables. So when you want to read through the table, you don't go through multiple columns. All you need to do is just focus on like 5 or 6 columns. So these are a lot of techniques to be implemented in the database world, and it's part of the things that make our system very, very reliable and easy to scale. All right. So we also talk about Postgres, which is part of database, part of NoSQL database. And if you are not working with MySQL, if you are dealing with a NoSQL database, if you are not working with MySQL, it's either you are working with Postgres database or mostly Postgres database. Now you can now find yourself dealing or working with a lot of abstraction services that abstracts all this database application. Maybe when you find yourself working with a lot of database on all these third party or cloud providers, they all abstract all this MySQL underneath. These are the things they run, but they will tell you to select type of database you want to install or you want to run on. So Postgres is also an open source, and it supports advanced queries and transaction, popular in every data application. When your system is going to deal in large data sets, every data application, and also it supports a flexible data models as well. So that's where Postgres and MySQL comes in. Now we now have the part of a NoSQL database. MongoDB is the one of the largest and the biggest database that supports NoSQL. And this is the one, me as an engineer, this is the one I have experience working with when we are talking about NoSQL databases. So it's very, very easy to use. It's very, very it's very, very easy to use, easy to set up, and easy to scale, because I've had an experience scaling the database on MongoDB server. So we all can look up into MongoDB server and how to use it. Do we have any question? Do we have any question? Um, I'm not getting any feedback. Oh. Do you have any question? All right. We so what I mean about being flexible to use, you can save data, you can specify the data you want to save in a query model the model, you define a model the same way you define it in MySQL, and also define it in a JSON like object and save it in the Postgres. That's where something a column data called JSONB comes in. We understand that NoSQL is always in JSON, which is MongoDB. It will always be in JSON, but Postgres also supports a column entity called JSONB, where you can save your data as a JSON object, but it will still store all the respective data that belongs to the that specific column in a structured data. Now, when you not all your record is being saved as a JSON object, it's only like a specific column is being saved as a JSON object. Now, another question I'm expecting people to ask is that why if you are going to design a system, why should we use Postgres over MySQL? Postgres, when you have a system that is like every time it writes you it belongs on every write. That is that you want to be writing to the database every time, saving data, saving data, saving data. Postgres is the best. But if the data, a system we are building is more on write, is on every write, every read, you have to be retrieving data, retrieving data, retrieving data every time. MySQL database is our go-to. For example, let me give us an example of a system that is more of every read, like a system that a read time a read time system where you have to keep receiving data, pam 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 pam, and keep writing data into data and keep fetching, viewing data. For example, let us assume we are talking about a map application whereby when you open the map, you can see your real-time location on the map. The moment you change your location, you will also see where you are on the map. So this kind of data is writing, 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 writing every time, every seconds. But you can also reduce this time of seconds whereby you calculate data distance between the last point, last coordinate points to the next coordinate points. You can limit it if the distance is nothing less than maybe a 5 kilometer radius or 5 kilometer, 2 kilometer radius, not to write. But yeah, this is kind of system that is heavily on write, but more system that is heavily on read, like a blog application. All this CNN, BBC, they are more of heavy read, whereby people will read more than they save data into the database. Something like Twitter or all this Instagram, people read more than people write. So it's more on heavy read than heavy write. All right. So comparing my SQL to NoSQL. So the data structure, like I explained the other time, is more of a structured data in tables. You save data in SQL in form of tables, and in SQL is in documents. Also, the schema is predefined, is a strict schema whereby you have to follow the way the schema is being designed. If you want to design a table in MySQL or Postgres, you have to give it a name. All the column have to follow a proper naming convention. They have to follow attributes convention for the data and for the columns. You can have an auto increment column that should be an integer. Those are the type of the things that we call strict. A specific auto increment column need to be an integer. You can't have an auto increment column that is in string. So SQL is more strict, and schema following schema functionalities on NoSQL is dynamic. It's not schemaless. You will be the one as an engineer, as a user, specify the type of schema you want to use on your database, which is on MongoDB. Scalability, vertical scaling, increasing the server power. That is, when we talk about vertical scaling, you're talking about the part of sharding or partitioning database. That is, if we talk about the partition, that is that you partition the database, you duplicate it, things like that. And sharding is where I explained the other time, whereby you split the tables, you split the tables. So, and the horizontal scaling is adding more nodes to the server of the database. That is, you add more nodes to it, like increasing this disk, increasing the what else do you increase? You increase the memory. You add more nodes to it to duplicate the instance of that server. That's the best word for it. You duplicate the instance of the server. So you can tell this a server, let us assume you have like a 5 GB server configuration you are running on your MongoDB, and data is now slowing down. You're unable to read very well properly on database. You can increase, you can, I mean, you can create multiple instances. All you need to do is just add more instance to it. So then the use case, complex query. You will be the one to define the query you want to write in MySQL. So that's where you deal with queries. You have to understand how to write query very well. You have to understand how to write proper query in SQL. You have something we call select all, select star in MySQL. Understand when you need to write select all, that is select all column in a table, and understand when you need to select a specific and predefined column in SQL. Understand the performance that comes with selecting all the column in a specific table than selecting a single or 3 or 4 columns in the table. Select the only column that you need. Imagine the type of table I explained the other time, that we have 8,000 records. Now, you want to select the user information like their name, their age, their date of birth. Now you select all the column. This operation is very, very expensive in the data sets. We have 8,000 records. You want to select just 5 column: name, first name, last name, age, and date of birth. Select all will take longer time to execute than just writing select first name, comma, last name, comma, age, comma, date of birth, comma, 4 column. It will execute faster than selecting all. So then, transaction. What do you mean by transaction? Transaction is the part where you try to write into database, and this operation you are writing into multiple database and multiple tables. Like, you are writing into 3 or 4 database and 3 or 4 tables in a single execution. So the word transaction means that when you are performing this operation, you are writing into 3 or 4 tables. When if the first execution is successful, the first table execution is successful, second table execution is successful. Now the third table execution now fail. You need to be able to revert all the operation, the 2 operation that is successful. You need to be able to reverse it. You roll back. That's what we mean by transaction. All the 3 execution, you want to perform 3 execution in a single operation. The first 2 is successful, the last one now fail. You need to roll back. All right. So now, mm, uh, okay. So now, what do you mean by Okay, do we have any question before moving on? Hello, do we have any question? um um Hello, are you guys here? I can't. I'm not getting any feedback. I'm not getting any feedback here. I'm not getting any feedback. Oh. Okay, somebody just asked, is transaction like a method or query? Yeah, is not a query. Is a method. Is a ways of handling. It's not a query. So inside the transaction is the design, but when you are dealing with backend, all you write is API. You write API, API, API. This is when you are interacting with your front end person that, oh, I've updated the API documentation. Oh, go and recheck. Oh, I've completed this specific feature. So I will share the API documentation with you. This is how you interact with your front end engineer compared to UI UX that design interface and give front end engineer the interface, and front end will be the one implementing the interface, translating the Figma design or Adobe design to readable and understandable design. But backend person, all you do is build API. You give them access to the API and they bind the API into their design. All right. So what do we mean by API? Application programmable interface. Is just so basic, but it's very, very powerful and very large. A set of rules and defines for how such an application can communicate with each other. This is very, very crucial to understand what we mean here. Let me give us an example. When you want to read a news, the API is fetching the post. That is get API. When you want to create a post, you are saving data to the database. The, the operation you are performing is that you are writing, you are creating a record. That's a post request. Now, I can remember our React system that we built that we I think 2 weeks ago, if I'm not mistaken, we built a single page application using a public API. If you can remember, the API is a public API. We interact with that API and we were able to populate posts on the web page and also write to the post. So we interact with API. So that's what backend engineer will be giving to a front end, not a design. You give them a set of rules, set of APIs to implement into their front end design. So that's what API is all about. I believe we've had one or two experiences with it, and I believe by henceforth we are going to be talking about more on how what is API and how API behaves. So also, why use APIs? It allow interaction between the front end and back end. That is what I just explained. The front end person will be the one integrating the API, while the back end person will be the one writing and supplying the API to the front end. Back end person will be the one that couple the API behavior with the database and put the API, deploy the application to the server. Do we understand? You plug your API to the database, respective database you want it to work with, and you still be the one to deploy that set of API you build to the server. So all you need to do is just give the front end person the URL to the application, not the URL to the database, because the application will be the one communicating with the database. All right. So used to connect third party services like payment gateway, authentication services. This is very important. What do we mean by payment gateway? On every application that you are meant to make a payment, you can find yourself using your payment, multiple payment options like bank transfer, like bank transfer, pay with your ATM card. So payment gateway is being integrated into the backend. It's a third party service, authentication service. You can manage your authentication using, I believe we've had experience with all this application whereby when you want to log in, omo, um it is 8 o'clock already, and we are going to have to take our break right now and come back after the break. Hello, can everybody hear me? All right. So what I'm explaining the other time is the authentication services. For example, I believe every one of us must have had one experience or the other with how to sign up or log in on a specific website where they instruct us to register or log in with the Google service. So you are going to find us on the web page email password, and maybe under it or above it, you'll find a Google icon where you can just click on the Google icon, and instead of you putting in your credentials, the Google will handle the login and registration for you. So that's an integration with third-party authentication services. So, and this is one of like two authentication services available. We also have Okta. It's also a third-party authentication services that you can use instead of using Google. So, okay, so now the other time we explained something called RESTful APIs. So, not every time okay, let me explain what we have API for. Now we have RESTful API, which is known as representational state transfer. That is, it is being used to transfer data and is being used to interact with the database. Now, an architectural style of building the API, there are multiple styles, multiple pattern you can use to build your services. For example, we can use a services called microservice application, microservices, whereby all the API is going to be function as a single services, all the functionalities. For example, the user system we are talking about the other time, all the API that belongs to user will run on a single service. All the API that belongs to the user education will run on a single services. So that's the style and architecture of building. And you can decide to have everything to run on a single service. That's called monolithic architecture. Now, I explained the other time that we have multiple HTTP methods to interact with the API. We have get to fetch and retrieve all the data, post to post the data to the database, that is to save, and put to update. Why delete is meant to delete the records from the database. Now, as a backend engineer, maybe when you are building on this, designing your application, you might not necessarily not interact with API. That is, you don't interact by API. You can interact with something called I want to remember that terms. Um, okay, so I can't remember right now. So, but it's not only APIs methods we use to interact with the system into with our database and provide it for the front end people. Okay, we have something called the gRPC. Yeah, I remember. gRPC is what we use. It's like an alternative to the API. And also we also have the XML pattern of writing an API as well. So all right, so now another key concept of an API is a data entity. So every resources in the API is solely designed and to map and explain what they are doing. For example, when you have get users, this specific user, that means you are this API is meant to retrieve all the users, get products, is meant to retrieve all the records in database that belongs to products. If the method is get, you want to get. If the method is post, you want to create users. If the method is delete, you want to delete a user. So now this is now an example. We have get to retrieve a list of users, to create a user, and user slash ID, the ID of the user that we want to update, and also delete the ID of the user that we want to delete. So this URL, you can have multiple query parameters. This one that we have here is called query parameters because it's part of the URL and is a parameter. It might not necessarily be one. It might be 100. It might be strings, or it might be alphanumeric. Depends on the ID that we are using in our database. So now the architecture of the backend. The other time when we start, I explained that as a backend, you will be interacting with the server, the database, and the API. So the API is where you build all the logics, you handle the logics and the connection on your database and deployment of the application, the API to the server. So the server handles request and serve responses, which we've explained the other time. When you ship this application, you deploy it on the server. The server, when the request comes in, it will eat the server first before it actually interacts with the API. So you can set up something called an else API to get the status of the server, to actually understand if the server is running. The server can hold as much as many API resources. You can deploy a lot of things on the server. For example, we are working with a cloud provider. Let's assume we are working with Google Cloud or AWS or Azure. You can use any of their services to deploy and host your API. If you are working with Azure, you can use Azure App Services. You configure the app service, the server, you configure the engine you want to run on the app service. Do you want to run a Linux service or you want it to run in Windows? You configure the size you want the computer to have, or the app service to have. The same thing goes for Elastic Beanstalk on AWS and Google Cloud Run on Google Cloud. You deploy your API to it, and you can now set up something called a CI/CD, continuous delivery and development and deployment on on the application, whereby the code environment where you deploy your code, where you hosted your code, the version control you are using for your code will automatically deploy the app, the API to the server. And if you don't want to use a managed server, that is a managed server, like I explained now, the Cloud Run, App Service, and Elastic Beanstalk, all these two things are managed server on the cloud provider. You can decide to use a service that you can manage yourself, like a virtual machine. All you need to do is just buy a specific virtual machine, and you set up, you SSH into your virtual machine, install all the things you need in the virtual machine, the way you install everything on your laptop. When you want to run React that time, what are the things you do? You install Node.js, npm on your computer. It's the same step you choose to do when you SSH into your VM on the server. All right. So you can also set up the application, the database on the server. You can decide to set up a database inside your VM, whereby you'll be the one to manage the VM, database VM yourself, or decide to use the managed database services. For example, a managed database service on cloud and Google Cloud is called Cloud SQL. Is a managed database services. All you need to do is just pay as you use it. Also, on Azure, we have flexible MySQL services. You create it and you pay as you use it. The same thing goes for AWS. You create the service of MySQL service and you pay as you use the service. All right. So this will be the end of our class, and also the takeaway on all these things we've been talking about on the backend part of the system is to understand that the backend development powers the server, also handles the database and the API logic. These are the things as a backend person we are going to be doing, and the server side language like Node.js, Python, PHP, and many more. But for the all of this mentorship program, we are going to be using Node.js. Understand reason why we are using a specific database, understand how the database handle performance, how the database handle data itself. Also understand how the database is being the connection with the database, because when you have all this database set up on the cloud, whether it's a managed service or you create the database yourself, you manage the database yourself inside the VM, you need to set up the IP of your database. To you whitelist all the IP address that can access this specific database. And the same thing goes for any application you hosted on the server. This also falls under the part of the security. You limit your application from a specific region, specific API request. Any API request, any IP address that is not whitelisted on these services, you cannot access it. So that's another ways of limiting request or protecting your service. It also falls under security. Um, that is all for our class for today, and I will actually want every one of us to ask one or two questions, because the next class we are going to be having on this backend is going to be more of codes, because today is more of just explaining, and we should get our mind prepared for the next class, and for the rest of the class is code. Yes, somebody asked if you can build an API locally on your system. Sure, you can build API locally on your system. The same way we build React application on our system, we can build it on our system. You set up a database on your system, you build the application, you install Node.js, and you run it on your application. These are the things we are going to be working on in our next class. I will walk us through how to set up database, how to set up the Node application, how to create it and run it, and build a specific API functionalities. So I hope that answers your question. Any more question? Any other question? So it depends on the system we are building, but using RESTful API mostly is the best because it depends on all the system we are building. Imagine you are building a real-time system. We are not going to be using REST API for that. We are going to be using a WebSocket for that because it's not going to be communicating over the HTTP protocol. It's not going to be communicating over that. And maybe if you want to build a system that you actually want to let it be fast, exchange data serially, is when you are using gRPC. But generally, RESTful API handles everything we want to the best on any system you want to build. All right. In the absence of no other question, that will be the end of our class for today. And I hope to see you guys in the next class. Thank you and have a nice night.